Okay, so let's move on to practice set 2.2, question number 4. Question number 4 says, write any three rational numbers between the two numbers given below. So two numbers will be given to you. Between those two numbers, you have to write any three rational numbers. Okay. Now, before continuing this sum, I want you to repeat the definition of rational numbers. Two definitions. Tell me both the definitions of rational numbers.
Numbers which can be written in P upon Q form and Q does not belong to 0.
And the second definition? Unmute.
Decimal.
Yes. Decimal expansion should be
decimal expansion, which decimal that
should, yeah.
Decimal that have decimals that are recurring and non-terminal.
Non-recurring and
terminal. Non-terminating are irrational.
Irrationals. Oh, okay. Sorry. You said rationals, no? Okay. Tell me irrationals. Rationals, you said rational numbers are the numbers which can be written in the form of P by Q. Correct? Now, irrationals will be numbers which cannot be written in the form of P by Q. And the second definition of irrational is decimal expansion a number whose decimal expansion is non-recurring, non-terminating. Irrationals, correct?
Yes, sir.
Okay. So now in this, they have told us to find three rational numbers. Okay. So think about the definition. Rationals, which can be written on the form of P by Q. Irrationals, which cannot be written in the form of P by Q. Okay. So first one is 0.3 and minus 0.5. Can you tell me any three rational numbers between these two?
0.1, 0 and 0 minus 0.2.
Correct. Second one, can you tell me minus 2.3 and minus 2.33?
Minus 2.5, minus 2.10, and minus 2.25.
Little bit incorrect, that is. I'll tell you why. Think a number line. This is 0. This is minus 1. Suppose this is minus 2. And after minus 2, somewhere here it will be 2.3. And after this will be something minus 2.33. It gets smaller and smaller. So between these two, you have to tell me between.
Minus 2.4.
2.4 will come here. It will come after this 2.4. Minus 2.4. I need between it.
I don't understand, sir.
But did you understand the question? But
that in between two numbers, you have to write three rational numbers.
Yes.
Yeah, I understood the question, but I don't understand this one.
Okay, but you understood why this is minus 2.33 first, and after that why minus 2.33 will come?
Because the smaller the number in minuses, it is near to positive.
Yes, correct. So think of it like this. So minus 2, if this is minus 2.3, then after that it will be minus 2.31. After this it will be minus 2.32. After this it will be minus 2.33 and so on. Like this it will go on further. So minus 2.3 can be also written as minus 2.30. Okay, this is minus 2.3 can be written as minus 2.30. Then after that 0.31, then 0.32, then 0.33. Now can you tell me any three rational number between?
Minus 2.32, minus 2.31,
1,
minus 2.32,
one more. You can even say it like this. Minus 2.311. This also will come between because it gets smaller and smaller. So it will be in between that interval. The more number you put here, the more smaller it gets, and it will come inside this interval only. Did you understand?
Yes, sir.
Okay. I'll just erase this. Okay, third one, 5.2 and 5.3.
5.21, 5.22, and 5.23.
Correct, absolutely correct. Next one, minus 4.5 and minus 4.6.
Minus 4.51.
4.51 will go out. This is negative. Now keep in mind between negative and positive. So if this is a number line, this is minus 4.46, minus 4.6, and if this is minus 4.5. So 4.51 will come here outside. I want it between it. Did you understand what I'm trying to say? 4.51 will...
Wouldn't 4.6 come this side?
Oh. Yeah, I did a mistake. (4.5) Then 4.51 is correct. Yes, 4.51. Then
4.57
minus 4.57 and minus one more.
Minus 4.61.
4.61. 61 will come outside.
Oh yeah. 4.5.
5, 8, 5, 9, take anything like that. So it will come between it. Okay, so the answers that I have given here are different, but what answer you have given, they are also correct. So see, 3.1, 3.2, 3.25. It will be between it. The three rational numbers between 5.2 and 5.3, as you said, 2.1, 5.21, 5.23, and 5.22, they are also correct, and this is also correct. 2.1, 2.4, and 2.8. And lastly, between minus 4.5 and minus 4.6, minus 4.51, minus 4.52, minus 4.53, 58, whatever you take will be correct. So will you write this sum later on?
Okay, sir.
Okay. See that you show me the, send me whatever you write. Okay.
Yes, sir.
Okay. Now we'll move on to the next concept called surds. Let us understand what is surds, and we'll then start the sums on surds. So firstly, we know that 5 is a rational number. Yes. Yes or no? 5 is a rational. And
Yes, sir.
root 5 is not rational. That means root 5 is irrational. This is a rational. And if you just put a root to it, it becomes irrational. So square root or cube root of any real number is either rational or irrational. It can be one of those two. You take a real number and you take the square root of it. This can be rational or it can be irrational. But in this case, root of 3 is rational. Let's see another example. If I take a real number 9 and you take the square root of it. So the square root of 9 is 3, while this is rational. So this statement says that you take the square root or you take the cube root of any real number. That can either be rational or irrational, one of those two. Is it clear?
Yes, sir.
Similarly, nth root of any real number is either rational or irrational. What do you mean by nth root?
11, 12.
11, 12? Just 11 and 12?
No, 10, 9.
Any root. So when I say square root, it means this. When I say cube root, that means you'll put 3 here. When I say fourth root, you'll put 4 here. When I say fifth root, you'll put 5 here, and so on. So that way, nth root. So you keep taking root. Square root means you square it, you take the root 1 time. Cube root means you take the root 3 times, and so on. So similarly, nth root of any real number will either be rational or irrational. Okay. If nth root of a real number A, of a positive real number A, is X, then we write it like this. Okay, read this statement. This statement says that if n is an integer greater than 1, and if A is positive real number, then nth root of A is X. Okay, nth root of A is X, and that is written like this. Did you understand this? Yes or no?
Yes, sir. But sir, what's that symbol for n, sir?
This one.
Yeah.
It is called as nth root of A. Nth root. Now that n
Oh,
depends.
that's
It depends. It can be
it's
2.
an n. Oh,
It's an n. It can be 2. When I say cube root, it will be 3. When I say
3,
fourth root, it will be 4,
4.
and so on. So it depends on which number is
So it
taken
can
in the
be
question.
any.
Yeah, anything. It can be any integer, positive integer. Okay. It can be any. It can be 10, 12, 13. It can be 100 also. It can be above more than 100 also. That depends. Okay. So nth root of any positive integer A is X, and that is written like this. Okay. So nth root of A is equal to x. Now, if this x is irrational, if this x is irrational, it can be anything. It can be irrational or it can be rational. One of those two it can be. But in this particular definition, I'm saying if this is irrational, then x is called as a surd. Okay. If x is irrational, then x is called as a surd. Did you understand? What is the meaning of
Yes, sir.
surd? Okay.
If
In a surd, if nth root of a is x, then this root sign is called as a radical sign. Okay, the root sign is called as a radical sign. Did you understand the definition of surd? What is
yes, sir.
surd? Can you repeat?
It is a if
And
how do it if
okay, I'll repeat it for you. If you have a positive real number a, okay, if you have a positive real number of a and you take its nth root, any root, square root, cube root, fourth root, fifth root, any root, and if you get that equal to x, now this x, it can be rational or it can be irrational, any one of those two. But I'm saying if it is irrational, then x is a surd. Understood? If it is rational, it is a surd. If it is rational, it is not a
then
surd.
not sir.
Okay. And this root sign is called as a radical. Okay, root sign is called as a radical. Understood? Now can you repeat? Can you say it in your own words?
Yes, sir. If n the if we take the nth root of a and it is an irrational number, then x is a surd.
Okay, good. And a should be a real number. Okay, this a inside, this should be a real number. So when you're saying, you say if you take nth root of any real number a, and
Yes,
if
sir.
that you get equal to x, and if x is irrational, then it is a surd. Understood?
Okay, sir.
Let's see examples now. Okay, one more thing. This is called as a radical, and inside this, which real number is there, that is called as a radicand. Okay, inside this, whatever real number is there, that is called as a radicand. This is called as a radical. The sign is called as a radical sign. And the real number inside it is called as a radicand. Are these two terms clear? Radical and radicand?
Radicand. Yes, sir.
Okay. Let's move on to the next. Okay, first one, if a is equal to 7, these are some examples, okay? And n is equal to 3. So our general form was like this, okay? Now they're saying if a is 7, that means here you have to write 7, and n is 3. That means cube root of 7. Correct? Now, is this a rational number or an irrational number?
The answer, right, sir?
Yes.
It would be a rational number.
Cube root of 7. Cube root. Is it rational or is it irrational?
Yes, sir. Yes, sir.
See, the root sign is still remaining. The root sign is not going even if you take the cube root of it. This radical sign is still remaining. So will it be irrational? Can you tell me something about this? Cube root 125. What is this?
Yes, sir.
Yeah.
It's an irrational.
This is
It's an
irrational.
irrational.
What about this?
Cube root of 125. It's rational.
It's rational. Why? Because cube root 125 is
5.
5. And 5 is rational. So this is also rational. But in this case, the radical sign is not going away. So this is irrational. So that is why this is a surd. Understood the difference between this one and this one? Why this is a surd and why this is not a surd? Yes? I hope
Yes,
no,
sir. Yes.
no confusions. Okay.
Yes, sir.
Let's see the second one. A is 27, N is 3. So you have cube root of 27. Now you tell me, is this a surd or no? And give me the reason also why it is not or why it is a surd. What is cube root of 27?
It's 3.
It's 3.
So.
And yeah, correct. It is 3. And what is 3?
It's
Rational.
It's
So is this a surd?
rational. No, sir.
No, it is not a surd. Good. Okay. What can you say about this next one? Cube root of 8. Is it a surd or not?
It's a surd.
It is a surd. This is a surd. Okay, cube root of 8, it is a surd. Okay, there is a proof why it is a surd. See, let's see this example first. Cube root of 27, can you tell me why this is 3? See, if you multiply 3 into 3 into 3, what do you get?
27.
27. That means 3 cube is equal to 27. Okay, 3 cube is equal to 27. That is why we can also say, since 3 cube is 27, cube root of 27 will be 3. Do you understand this?
Yes, sir.
Okay. In the very same way, cube root of a, suppose if it is some number p, which we don't know. Okay, that means 8 will be equal to p cube. 8 will be equal to p cube, correct? Is there any number whose cube is 8? No.
No.
No, there is no such number whose cube is 8. That is why directly we can say that cube root of 8 is a surd. Are you following?
Yes, sure.
Okay.
So,
Yeah.
Isn't 2's cube 8?
2 to the 4. Yeah. 2 cube is 8. So cube root of 8 will be 2. Yeah. So this, is it a surd or not a surd?
It's not a surd.
It's not a surd. Okay, good. So you're understanding. Okay, how about 4th root of 8? Is this a surd? That means 4th root of 2 is 8. That means there should be some number which you take it to the power 4 should give you 8. Is it possible to get such number whose 4th power is 8?
No, sir, I don't think so.
No. So then what can you say about 4th root of 8? Is it a surd or not a surd?
It's a surd. It's a surd.
It is a surd. It is a surd. Okay, good. So now you can identify now which is a surd and which is not a surd, correct? Okay, I'll give you a few more examples. You tell me whether it is a surd or not a surd. Square root 25.
It's not a surd, sir.
It's not a surd. Okay, good. Fourth root of 16.
Not a surd, sir.
Not a surd. Not a surd. Why it is not a surd? Because
It's 2.
yeah, answer is 2. 2 raised to 4 will give you 16. So it is not a surd. Okay, good. What about this?
It's a surd, sir.
It is a surd. Okay, good. So now we can move on to our sums. Okay, in the sum, in the exercise, we will be seeing only second order. That means only square root surds will be seen. We'll not be seeing cube root, we'll not be seeing 4th root, 5th root, and so on. We'll be only seeing square root of, we'll be only having examples of square root of surds. Okay. Also, one thing, this the surds of order 2, that means square root, they are also called as quadratic surds. Okay, this point keep in mind, quadratic surds, that is surds of order 2, meaning square roots. Okay. Is it clear what is quadratic surd? Yes or no?
Yes, sir. But sir, could you give me an example?
Quadratic surds.
Yes. Yes, sir.
Yeah, this yeah. Quadratic surd like root of 2. This is a quadratic surd. Root of 3. Again, this is a quadratic surd. Will this be a surd? It's a quadratic, but is it a surd?
No, sir.
No, it's not a surd.
It's a rational number.
It's a rational number. Okay. So root of 5, again, this is a quadratic surd. So only square roots. We're not taking any nth root. No cube root, no 5th root, no 4th root, no 6th root, and so on.
Sir.
Just second root or order 2. They are surds. something like root of 6. This is also quadratic surd. That means writing no number here. That means square root. Okay, now the next thing we have to see is the simplest form of a surd. Now, just like how you can reduce fractions, okay, we can reduce fractions. Like, for example, if you have 4/8, this fraction you can reduce. 4 ones are 4 twos are. So 1/2 is called as the simplest form of the fraction 4/8. In the very same way, you can simplify a surd also. Let's see how to simplify surds. So very first one, we'll see root of 48. Okay, I'll show you the prime factor method to simplify this. So you find out the prime factors of 48. How do you find prime factors of 48? Can you tell me? Unmute.
We find numbers which are in their tables.
Yeah. So can you tell me prime factors of 48?
12.
No, you keep dividing it by 2, right? This is an even number divisible by 2. So divided by 2. So 2, 2s are 4, 2 4s are 8. Again, it is divisible by 2. So 2 1s are 2, 2 2s are 4.
2.
Again, divisible by 2. So 2,
6.
6. Next,
2.
2. And here,
3.
3. Now, can I take 2
3.
again? No. So 3 1s are. So when you get 1 here, you stop.
Yes.
So now you write all of these prime factors inside the root. So 2 into 2 into 2 into 2 into 3. Correct? Now you take pair, you pair it. So this became one pair, this became one pair. So whenever you have got the pair, you separate the roots in the pairs. So this is 2 into 2, then second pair 2 into 2, and 3 single. So that also you write, give it a root separately. Correct? Now you'll get root of 4 into root of 4 into root of 3 as it is. Now what is root 4?
Four is 16.
Root, square root 4. Square root 4.
Oh. 2.
2. 2 into again root of 4, 2, and this root 3 as it is. Now 2 into 2,
4.
So this will become 4 root 3. 4 root 3 is the simplest form of your surd root 48. Understood? This so many steps you can reduce by just looking at your prime factorization. So look at your prime factorization. You just make pairs. So this is one pair, this is next pair, and 3 single. 3 single. Okay. So from this pair you take 1, 2. From this pair you take 1, 2, and you multiply them. 2 into 2 is 4. And whichever number is single, that you write it in the root. So root 3 is single, there is no pair, so that you write it in the root. So our answer is 4 root 3. Did you understand both the methods?
Yes, sir.
Okay. So this so much calculation can be reduced just by the prime factors. You can get your final answer, 4 root 3. Clear? I want you to write this sum.
Yes.
Write it down.
Sir. Done, sir. Done.
Okay. Can you try to simplify the second one, root 98? Simplify this, write it in the simplest form. Same thing, first find out the prime factors. Will you able to do it?
Of 98, sir.
Yes.
Okay, sir.
Try it, do it. First find out all the prime factors and tell me and just show me your prime factors.
And do you have the original emails happy to
So we have to pair numbers which are of the same numbers, right? We have to pair the same numbers, right?
Yes, yes, same number pairs and which are single, that will go inside the root. But you write it in the way how I showed it to you, okay? The first sum how we did, no? Write it that way.
So the prime factor I got were 2, 7, and 7.
And the final answer?
7 root 2.
Correct. Can you just put your book in front of the camera and show me your calculations? Okay, I can't see it. Is it possible for you to send a photo?
Yes, sir.
Okay. Can you do it right now? If possible, do it now. Otherwise, you can send it to me later. Yes, Chris, can you hear me?
Yes, sir.
Okay, one small mistake, I'll show it to you. Okay, you have written, after this step, look, 7 into 7 and root of 2. That is 1, 2, 3.
But do account में difference एक नहीं.
Fifth line, look at the fifth line. You have written 7 into 7 and into root 2. Did you get it?
दो account में difference
Okay.
है, दो
Now
match
after
है.
this, you wrote then 7 into 7, 49
Hello.
and root of 2.
दो account
Correct?
में difference है और दो match है.
Now what is root of 49?
7.
7. So just write 7. You have put a root sign on it also. So don't put this root sign. Just write 7.
क्या?
So 7 root 2. I'll erase it.
वर्मन का match है.
So like this, just like this, 7 root 2. Remove that root sign from the 7.
South ये अपना.
And you have written the final step also, you have put double root sign. Remove that as well. That's wrong. You have written it like this. Root 7, root 2. Okay, this is wrong. Stop here itself. 7 root 2. If you're getting confused, you just look at this prime factorization that you did. 2 into 7, 7 and 7. So this 7 is common, so put it 1, once only. And root 2, 2 is single. So whichever number is single, you just put a root sign and write that number inside that root sign. So 7 root 2 is your answer. So it should match. Understood? Correct it just now. Correct it on your book just now.
NY में नहीं है. Okay, आप बोल रहे हैं NY है.
Done, sir.
Also, one more thing, put equal to signs here. You have not put equal to sign anywhere. Put
Oh,
equal
yeah.
to signs everywhere.
23 था, उसे पूछा नहीं, बिना पूछे उसे पढ़ी.
Done?
के बाद वायर ट्रांसफर किया. तो वायर में
Okay.
अब चेक उनको 5 तो वो चेक वो कैंसिल होना था. उसने वॉइड किया नहीं. तो ऐसा है कि मेरे पास जो कार्ड नंबर उसने दिया है मेरे को अलग अमाउंट है. अब क्या करें? अलग अमाउंट है बट सपोर्टिंग ईमेल भेजा है उसने कि वो बोल रहा है ईमेल में है कि ये पेमेंट ऐसे
Okay.
करके.
Next is similar or like search.
अभी क्या करना?
Okay, similar or like search. Now, if P and Q are rational numbers, then P root A and Q root A are called as like search. Now, these two searches will be like if P is equal to Q. Okay, if P is equal to Q, then these searches are called as like searches. Did you understand?
Yes, sir.
राजेश्वरी से बात कर.
Okay, if you read this statement here, it says two searches are said to be like if their order is equal. By order, we mean if it both should be square root or both should be cube root. But since we are studying only of square root, both should be square roots. So if their order is equal and radicands are equal. What is radicand?
Numbers which are inside the radicals.
Correct. That is radicand. So two searches are said to be like searches if their order is equal order, that means they both of them should be square roots, and their radicands, that is a number inside them, should be equal. Okay, now look at this example. Root 45 and root 80. Now both these surds are square root, that means they have order 2. But are they equal? Are they equal?
No, sir.
No, they don't look equal
No.
because the radicand is not equal. This is 45 and this is 80. But we can do one more thing to check whether they are equal or not, and that is we can simplify these surds to the simplest form. We'll do that. Is it possible to simplify? Yes. Yes or no? We'll simplify
Yes,
them.
sir.
We will
Yes.
simplify and check again whether they are like surds or not. Okay, so let's start with 45. Root of 45. So first you find out prime factors of 45. Can you tell me?
9.
Start with 5.
3. 3 also.
Okay, 3. So start with 3. 3 ones are 3. 3 5s are 15. So this became 15 here. So 3 5s are 15. Next, what to take?
5.
So 5 ones are 5. So what will be the answer? Without writing, can you tell
3
me?
root 5.
Correct, 3 root 5. But when we are writing, be more specific. So 3 into 3 into 5, then you pair it. And once you pair, you separate the roots. So this will become root of 9 into 5, root of 5. And you know root 9 is 3. So this will become 3 root 5, as you said. Correct? Now let's check for root
Yes.
of 80. Tell me the prime factors. Start with, it is divisible by 2.
2.
So what will come here?
40.
40. Next, 2,
2 again. 20.
20. Then 2,
10.
10. Again 2,
5.
5. Next, you are muted. Unmute.
5.
5.
5.
Ones are. So can you can you tell me directly the answer? Pair it first. Can you tell me what will be the answer? Final answer?
Yes, sir.
Okay. So can you tell me what will be this answer?
1 second, sir.
Final answer?
Root 4.
Single is root 5. Root 5 has no pair. Sorry, 5 has no pair. 5 is single. So whatever number is single, that you put inside the root. Now this is a pair. From this pair you take 1, 2. From this pair you take 1, 2 and multiply both of them. What will be the answer?
4.
4. So that comes outside. So 4 root 5 is the simplest form of root 80. Understood? Yes. Okay. Now, are they like term? Are they like surds? Surds are said to be like surds, first of all, if their orders are equal and the radicands
No, sir.
are same.
They are not like.
Look at the definition. Two surds are said to be like surds if their order is
Sir, but their
equal.
order is not equal.
Order is equal, right? Both are square root. Here also you have square root 5. This is square root 5.
So that's cube.
This is also square root 5. No, it's not cube. It is 3 root 5. It is not cube root of 5. It is 3 into root 5. Now, can you tell me, are they like or not like?
They are like, sir.
They are like. So, keep the definition in mind. Two surds are said to be like if their order is equal and if their radicands are equal. Is it clear?
Yes, sir.
Okay, now I want you to write this sum and we'll stop after this. Okay, write down this. Wait, write as I say. The way I tell you to write it like that. First, write this question. Write this question here first. Did you finish writing?
Done, sir.
Okay, after that, write this root of 45 and then you find out the prime factors of 45. So that was 15, 5 and 5 ones are 5. So this you will write it as 3 into 3 into 5. Then you can separate it. So when you make the pair and 5 here. So this will become root of 9 into root of 5. And you know this is 3 and then the root 5. After that, you write root of 80. Then you find out the prime factors for 80. Is 10, 5, and 5 ones are. So you take the pair. I hope you have understood both to get the answer directly from prime factors method.
Yes.
Okay, don't get confused there. It's just that while writing, you write it like the systematic way. So you write it 2 into 2 into 2 into 2 into 5. Then you do the pairing. Once you have done the pairing, you separate the root pairwise, and whichever number is single, you keep it as it is with the root sign. Then they become root of 4 into root of 4 into root of 5. And you know square root of 4 is 2, 2, and this root 5 as it is. 2 into 2, 4. So this becomes 4 root 5. And now final answer. So you write since the radicand is radicand and order is the same for both the surds, these 3 root 5, the surd, 3 root 5 and 4 root 5 are like surds. Okay, the surds 3 root 5 and 4 root 5 are like surds. Did you understand the sum?
हेलो हाँ हाँ
Yes,
हाँ
sir.
विजय
Okay.
क्या हुआ पता है there is this one payment जो
Done, sir.
Chris, did you get textbooks or you're still using PDF?
I'm still in PDF, sir, but my school is right now week, so either they'll probably give us or
और
we get.
वो जो उसका
Okay.
बिजनेस था उसका वो पेमेंट अर्जेंट था तो उसने उसके बाद वायर पेमेंट किया 15,000 कुछ तो किया तो वायर
Okay, so we'll stop here. We'll stop here. Do for homework
this,
whatever sums we did today. Redo those sums. Practice it. And you have the first question also to solve. Okay.
उनको चेक भी मिल गया
First question also you have to solve. So you try that. Right? So we'll stop here. See you on Tuesday.
बैंक ने उसको रेमिटर
Bye, sir.
मतलब
Bye.
वो नहीं रहा था रेमिटर बैंक बिकॉज बैंक बोल रहा था कि अगर डुप्लीकेट पेमेंट है तो ओरिजिनल